Backfeeding a permanent electrical panel from a temporary panel is not a safe practice. There are several reasons why this method poses significant risks. Firstly, energizing a permanent panel without thorough inspection can introduce numerous safety hazards. These hazards could include overloaded circuits, open grounds, or even incorrect wiring configurations. Secondly, the temporary panel might not be adequately rated to handle the combined load of both the permanent panel and the circuits that are being backfed. This discrepancy in load capacity can lead to overheating and potential fire hazards. Thirdly, the neutral or ground bar located at the temporary pole might not have sufficient bonding to the grounding system of the permanent panel. Inadequate bonding creates a significant potential for electrical shock, endangering anyone who comes into contact with the electrical system. Fourthly, the breakers in the temporary panel might not be capable of effectively protecting the circuits within the permanent panel, especially in the event of a fault. This lack of effective circuit protection increases the risk of electrical fires and equipment damage. To safely energize the permanent lighting circuits, adhere to a strict procedure. Firstly, obtain a temporary use permit from the local electrical authority. This permit ensures that the installation meets all local codes and safety regulations. Secondly, connect the permanent panel to the temporary meter panel using an approved method, such as an interlock kit. An interlock kit guarantees proper grounding and reliable circuit protection, reducing the risk of electrical hazards. Thirdly, energize the permanent panel directly from the temporary meter panel. This direct connection ensures that power is supplied safely and efficiently. Fourthly, turn on only the desired lighting circuits that are needed for the painting work. This targeted approach minimizes the load in the temporary system and reduces the risk of overloading. In addition to these procedures, implement several additional safety precautions. Firstly, consider installing ground fault circuit interrupters, or GFCIs, for added protection against electrical shock. GFCIs are especially important in areas where there is a risk of moisture or contact with conductive surfaces. Secondly, ensure that the wire used for backfeeding is of the correct gauge and type. Using the wrong wire can lead to overheating and potential fire hazards. Thirdly, clearly mark all circuits that are being backed from the temporary panel. Proper labeling helps to prevent confusion and ensures that everyone knows which circuits are being powered from the temporary source. Once the painting is completed, promptly remove the backfeed wiring and restore the electrical system to its original configuration. This step is crucial to prevent any long-term safety issues and to ensure that the electrical system operates as designed. Backfeeding an electrical panel in the way described can create a dangerous situation for several key reasons. The equipment used for temporary power, such as the temporary panel and meter, may not be adequately rated for the load it would be supporting when backfeeding a permanent panel. Temporary power setups are typically designed for limited, short-term use and often lack the robust infrastructure of a permanent electrical system. Overloading the temporary system can lead to overheating, voltage drops, and potential failure of the equipment, increasing the risk of electrical fires and equipment damage. The temporary panel may not provide adequate circuit protection for the permanent panel and its branch circuits. Circuit breakers and fuses are designed to protect against overcurrents and short circuits. However, if the breakers in the temporary panel are not properly sized or coordinated with the permanent panel circuits, they may not trip quickly enough to prevent damage or injury in the event of a fault. This inadequate protection can result in electrical fires, equipment damage, and potential harm to individuals. The grounding and bonding of the temporary system may not be compatible with the permanent electrical system. Proper grounding and bonding are essential for electrical safety as they provide a low impedance path for fault currents to return to the source, allowing protective devices to operate correctly. If the grounding and bonding are not properly established between the temporary and permanent systems, it can create a hazardous situation where fault currents may flow through unintended paths, such as through people or equipment, leading to electrical shock or electrocution. The wiring methods used for temporary power are often different from those used for permanent installations. Temporary wiring may not be installed in accordance with the National Electrical Code, or NEC, or other applicable standards, leading to potential safety hazards. For example, temporary wiring may not be properly supported, protected from physical damage, or have adequate insulation, increasing the risk of shorts, shocks, and fires. Additionally, the connections made between the temporary and permanent wiring may not be properly installed or torqued, leading to loose connections, overheating, and potential failure of the system. When backfeeding a permanent panel from a temporary source, there is a risk of energizing circuits that are not intended to be energized. This can create confusion and potentially dangerous situations for individuals working on the electrical system. For example, if a circuit is inadvertently energized, it could pose a shock hazard to someone who is working on that circuit, assuming it is de-energized. Proper labeling and identification of circuits are essential to prevent such incidents, but these measures may be overlooked or inadequate in a temporary setup. Modifying an electrical system without proper authorization or inspection is generally prohibited by electrical codes and regulations. Electrical work should be performed by qualified and licensed electricians who are familiar with the applicable codes and standards. Backfeeding a permanent panel from a temporary source without proper permits and inspections can result in code violations, fines, and potential liability in the event of an accident or injury. It is essential to obtain the necessary permits and inspections before making any modifications to an electrical system to ensure compliance with safety regulations. The proper way to provide temporary power to a permanent panel is to use an approved method that ensures safety and compliance with electrical codes. One common approach is to install a transfer switch or interlock device that allows the permanent panel to be connected to either the utility power source or a temporary generator or power source. This device ensures that only one power source can be connected to the panel at a time, preventing backfeeding and other potential hazards. Another option is to install a temporary power panel that is separate from the permanent panel. This temporary panel can be fed from the temporary meter or generator and used to supply power to the necessary circuits. The temporary panel should be properly grounded and protected by circuit breakers or fuses to ensure safety. Always consult with a qualified electrician to determine the best approach for providing temporary power to a permanent panel and to ensure that all work is performed in accordance with applicable codes and standards. A more detailed breakdown of how to safely energize the permanent lighting circuits for the painters includes firstly, applying for and obtaining a temporary use permit from the local electrical authority. This permit ensures that all electrical work meets local safety regulations and codes, providing a legal and safe framework for the project. Secondly, before making any connections, conduct a thorough inspection of both the temporary and permanent electrical systems to identify any potential hazards, such as damaged wiring, loose connections, or inadequate grounding. Address any issues before proceeding to ensure a safe installation. Thirdly, connect the permanent panel to the temporary meter or panel using an approved method, such as an interlock kit or a transfer switch. These devices prevent backfeeding and ensure that only one power source can be connected to the panel at a time, reducing the risk of electrical hazards. Fourthly, verify that the grounding and bonding systems are properly connected between the temporary and permanent electrical systems. Proper grounding and bonding are essential for electrical safety as they provide a low impedance path for fault currents to return to the source, allowing protective devices to operate correctly. Fifthly, once the connections are made, energize the permanent panel from the temporary meter or panel. Use a qualified electrician to perform this step and ensure that all connections are secure and properly torqued. Sixthly, after energizing the panel, test all circuits and devices to verify that they are working properly and that there are no faults or abnormalities. Use appropriate testing equipment, such as a multimeter or circuit tester, to check voltage, current, and continuity. Seventhly, turn on only the desired lighting circuits that are needed for the painting work. Avoid energizing unnecessary circuits to minimize the load in the temporary system and reduce the risk of overloading. Eighthly, install ground fault circuit interrupters, or GFCIs, for added protection against electrical shock, especially in areas where there is a risk of moisture or contact with conductive surfaces. GFCIs are designed to detect ground faults and quickly interrupt the circuit to prevent electrical shock. Ninthly, ensure that the wire used for backfeeding or extending circuits is of the correct gauge and type for the intended application. Refer to the NEC or other applicable standards to determine the appropriate wire size and type based on the circuit's ampacity and voltage rating. Tenthly, clearly mark the circuits that are being backed from the temporary panel or extended from the permanent panel. Use labels or tags to identify the circuits and their source, making it easier for others to understand the electrical system and prevent confusion. 11thly, provide training to the painters and other workers who will be using the electrical system. Educate them on the safe use of electrical equipment, the location of circuit breakers and GFCIs, and the procedures to follow in the event of an electrical emergency. 12thly, regularly inspect the temporary electrical system to ensure that it remains in good condition and that there are no signs of damage or deterioration. Check for loose connections, frayed wiring, and damaged equipment, and address any issues promptly. 13thly, once the painting work is complete, promptly remove the temporary wiring and equipment and restore the electrical system to its original configuration. Disconnect all temporary connections and ensure that the permanent wiring is properly terminated and protected. 14thly, obtain a final inspection from the local electrical authority to verify that the temporary electrical system has been removed and that the permanent electrical system is in compliance with all applicable codes and regulations. This inspection provides assurance that the electrical work has been performed safely and correctly. By following these detailed steps and precautions, it is possible to safely energize the permanent lighting circuits for the painters while minimizing the risk of electrical hazards and ensuring compliance with electrical codes and regulations. It is essential to prioritize safety and consult with qualified professionals to ensure that all electrical work is performed correctly. Regarding additional safety precautions, consider the following points in detail. Firstly, always install ground fault circuit interrupters, or GFCIs, for added protection against electrical shock. GFCIs are designed to detect ground faults, which occur when electricity flows through an unintended path, such as through a person. When a ground fault is detected, the GFCI quickly interrupts the circuit, preventing serious injury or death. GFCIs should be installed in all areas where there is a risk of moisture or contact with conductive surfaces, such as bathrooms, kitchens, and outdoor locations. Secondly, ensure that the wire used for backfeeding is of the correct gauge and type. The gauge of the wire refers to its thickness, and the correct gauge must be used to handle the electrical load of the circuit. Using a wire that is too small can cause it to overheat, leading to a fire. The type of wire refers to its insulation and other properties, and the correct type must be used for the specific application. For example, some types of wire are designed for use in wet locations, while others are designed for use in high-temperature environments. Thirdly, clearly mark the circuits that are being backed from the temporary panel. This helps to prevent confusion and ensures that everyone knows which circuits are being powered from the temporary source. Use labels or tags to identify the circuits and their source, and make sure the labels are clear and easy to read. Fourthly, ensure that all electrical connections are properly made and tightened. Loose connections can cause overheating and arcing, which can lead to a fire. Use the correct tools and techniques to make sure all connections are secure. Fifthly, protect all wiring from physical damage. Wiring that is exposed to physical damage can be easily damaged, leading to shorts, shocks, and fires. Use conduit or other protective measures to protect wiring from damage. Sixthly, do not overload circuits. Overloading a circuit can cause the circuit breaker to trip, or it can cause the wiring to overheat, leading to a fire. Know the ampacity of each circuit and do not exceed it. Seventhly, never use extension cords as a substitute for permanent wiring. Extension cords are designed for temporary use only and should not be used as a substitute for permanent wiring. If you need to extend a circuit, have a qualified electrician install permanent wiring. Eighthly, inspect all electrical equipment before use. Before using any electrical equipment, inspect it for damage, such as frayed cords, cracked housings, or loose connections. If you find any damage, do not use the equipment until it has been repaired. Ninthly, use caution when working near water. Water is a good conductor of electricity, so use caution when working near water to avoid electrical shock. Never touch electrical equipment with wet hands. 10thly, know what to do in the event of an electrical emergency. If you see someone being shocked, do not touch them. Instead, call for help and turn off the power at the circuit breaker. If there is an electrical fire, do not use water to put it out. Instead, use a fire extinguisher that is designed for electrical fires. Once the painting is complete, it is crucial to promptly remove the backfeed wiring and restore the electrical system to its original configuration. This step is essential to prevent any potential safety hazards or confusion in the future. Failure to do so could result in unintended consequences, such as accidentally energizing circuits that are not meant to be live or creating a dangerous situation for anyone working on the electrical system. Before removing the backfeed wiring, ensure that the power is turned off to the affected circuits. This can be done by switching off the corresponding circuit breakers in the temporary panel. Double-check that the circuits are de-energized before proceeding with the removal process. Carefully disconnect the backfeed wiring from both the temporary and permanent panels. Use appropriate tools, such as wire strippers and screwdrivers, to safely disconnect the wires without causing any damage. Inspect the wiring and connections for any signs of damage or wear. Replace any damaged wiring or connectors to ensure the integrity of the electrical system. Once the backfeed wiring has been removed, restore the electrical system to its original configuration. This may involve reconnecting any circuits that were temporarily disconnected or reconfiguring the wiring in the permanent panel. Ensure that all connections are properly made and tightened to prevent loose connections or shorts. After restoring the electrical system to its original configuration, test all circuits and devices to verify that they are working properly. Use a multimeter or other testing equipment to check for voltage, continuity, and proper operation. If any issues are detected, troubleshoot and resolve them before putting the system back into service. Finally, document the changes that were made to the electrical system, including the removal of the backfeed wiring and the restoration of the original configuration. This documentation can be helpful for future maintenance or troubleshooting purposes. Keep a record of the date, time, and any specific details about the changes that were made. By following these steps and taking the necessary precautions, you can safely and effectively remove the backfeed wiring and restore the electrical system to its original configuration. This will help to prevent any potential safety hazards and ensure the continued safe operation of the electrical system. The information is not intended to be a substitute for professional electrical advice. Always consult with a qualified electrician for any electrical work.